Hello, hello children, hello students, and hello Bacha party. So after a long time we are doing one more PYQ, which I will say which is one of the toughest PYQs from the easiest chapter, that is quadratic equations. So welcome to everyone at Maths Mama. Let us see how to crack this toughest question on quadratic equations. See students, this was the question given in 2021. This was the mains question or advanced question that you will decide. But by seeing this question, we can say it was a very good question, very conceptual question, which is not of the pattern of the questions that they are asking from this chapter. Generally, when they are asking the number of real roots, you will see they make the coefficients same. But here, it is not being solved by that method. So how to solve it, we will see. First of all, see the question. What was question? Question was e power 6x minus e power 4x minus 2 into e power 3x minus 12 into this plus e power x plus 1 equal to 0. Find out total number of real roots of this equation. This was the question which was asked. See, students, we have solved many questions where we find the coefficient of this second term and second last term to be same. But here that is also not the case. Here e power x and e power 4x. So that way also we are not able to solve this question. So before seeing this solution, you should try the question by yourself, by your method. I will say spend 10 to 15 minutes on this question. After that, if you are unable to do, then we should see here, and definitely in most of the students you won't be able to solve this because it was very good question. All right, so let us see how to solve it. See, we have to find the total number of real roots. See, first of all, we observe the given equation. If we see the given equation, this is 1, 2 and 3. So if we combine this e power 6x minus 2 into e power 3x plus 1, we can easily write it as a minus b the whole square. That is e power 3x minus 1 the whole square. So e power 3x whole square will be e power 6x, 1 whole square will be 1, and minus 2ab will be this. So these three terms combined are e power 3x minus 1 the whole square. Clear? Clear to all? Alright. So all these three terms we have clubbed together and wrote like this. And after that, remaining all the terms we wrote like this. From here I am taking e power x common. So if I take e power x common from this term and this term, I will get e power x and e power 3x minus 1. That is, we are getting this term. And finally the last term we are writing as this. Okay, now observe how to solve this equation. Right? Now think how to go ahead from here. See, this is the equation formed, and first term is e power 3x minus 1 the whole square. Last term is e power x the whole square, and here you can see e power x and e power 3x minus 1 both. So what we are doing, we are dividing the whole equation number 1 by e power 2x. So if we divide by e power 2x, you will get this equation. Understood? So this is the equation that we are getting, and in this equation I am putting e power 3x minus 1 upon e power x as t. So after that we get t square minus t minus 12 equal to 0. Then factorize. t minus 4, t plus 3 equal to 0. So from here we are getting two values, t equal to 4 and t equal to minus 3. So I will say t1 is 4, t2 is minus 3. So let us go to next page. Yes, so t is 4 and t is minus 3. From here we are writing it as this, and now I am substituting e power x as t1. Then finally we got a cubic equation. Then how many number of real roots of this cubic equation are possible? If we are putting e power x as t1, then e power x is always a positive real number. So t1 is always positive. That means t1 you can put only values between 0 to infinity, right? Because it is positive. And this is a cubic equation. If we put t1 as 0, f of 0 will be minus 1. This is a cubic equation, polynomial equation, everywhere continuous and derivable. So f of 0 is minus 1, f of infinity will be plus infinity. Continuous and derivable function, and its dy by dx is also not 0. So we can say between 0 to infinity it will have exactly one real root. Similarly this side, this equal to minus 3, then this equal to t2, then we substituted, f of 0 is minus 1, f of infinity is infinity. Again here we have one real root. So one root here, one root here. Total number of 2 roots we have. Right, so it was a very good and different type of question on quadratic, where they are using the basic concept of factorization. We can see here factorization. If we are able to factorize this, then only we can do this. Apart from this, if you have some other methods, then also you can try whether you are getting the answer or not. So it was a good question. Hopefully you all understood this. So keep studying, keep working hard, and keep doing maths. All right, thank you.